Hi folks, we are once again back with this exercise 6.5 question number 3 where we had to find out the points of maxima minima. We are back with those problems. Let's take the 7th sub question. Till the previous video we have taken the 6th sub question. Now it's a 7th sub question. It says that g of x is 1 over x squared plus 2. We have learned it as a pattern that we will be finding the first derivative, we will be finding the second derivative and make the first derivative equal to 0, get the critical points and then check whether it's a maxima or minima point. That is going to be our format. This is the same, but only thing, this may not be as simple as what we did in the previous questions. Here it may call out for a little more work. Anyhow, let's see how we can do it. So let's go in to get the first and second derivative and see how that goes. Our first derivative here is going to be either that you can look at this function as a quotient u over v, where u is 1 and v is x squared plus 2. Either you can look at it like that and get the first derivative, or you, if you want, you can also look at it like this. It's x squared plus 2 to the power negative 1, to the exponent negative 1. And then you can get the derivative by chain rule and get the answer. So whatever is convenient to you, maybe we can do it. I think I'll go for chain rule and see how it is. So therefore this will be, first we'll take the derivative of the exponent, which will come to negative 1 times x squared plus 2 raised to negative 2, nx raised to n minus 1. Because of that, you first get the derivative of the function. Now we will try to get the derivative of the base that is given to you, that is x squared plus 2. The derivative of x squared plus 2 is 2x, because x squared has got derivative 2x, 2 doesn't have a derivative, so therefore you have the derivative as 2x. When we actually write this, it will be minus 2x over x squared plus 2 whole squared. This will be our derivative. So that's our first derivative. So as we know, we require the second derivative also. So let's find the second derivative. For the second derivative, I think we could treat, you can take the minus 2 outside and just look at this function, treat it as a quotient u over v and see how it comes. So if that is the case, then x squared plus 2 the whole squared stays as it is, and you find the derivative of x, which is 1, and then x stays as it is. You find out the derivative of x squared plus 2 to the exponent 2. So that's quite a laborious affair, because it is to the exponent 2, so the derivative there is going to be 2 times x squared plus 2 to the power 1, nx raised to n minus 1, and the derivative of this base function is going to be 2x. So that's how you are going to get the derivative of this term. Since it's a quotient that we are taking care of, so it's x squared plus 2 raised to 4, because you know the formula. The formula is maybe v times derivative of u minus u times derivative of v over v squared. You know, we write it like that. So that's how it is. It's the square. Now you're expected to solve this. If you want, you can solve it, or you can leave it like that, because it's finally that the value that you're going to substitute in it. So it's not that you have to simplify it. If you simplify it, that much better. So I don't think I'm planning to simplify it. I'll just try to, if there is some factor which we can cut off, maybe we can do that so that things become simple. So I observed that x squared plus 2 is common. So let me take that x squared plus 2 out. So if I could take the x squared plus 2 common outside, here there is 1 x squared plus 2 left, and the negative sign is there here, and one of the, this x squared plus 2 has gone out, so it stays as 4x squared over here. Yeah, and then there is this x squared plus 2 raised to 4, so these can cut each other. You will get negative 2 times, if you want you can simplify this x squared minus 4x squared, that's minus 3x squared plus 2 over x squared plus 2 now to the power 3, because we have made the cancellation. I think that's enough. So this should be fair enough. Now we can go for finding the critical point and then checking which is the maxima or minima point. So let's get across checking that. So we'll be having to find the first, to find the critical point. So let the first derivative be 0. That's how we go on to find the critical point. Then in that case, what happens? you get minus 2x over x squared plus 2 the whole squared equal to 0. So you can think of it like this is going on the other side and it's becoming 0, even negative 2 is going on the other side and that is also becoming 0, and finally you get x as 0. So after all the simplification you will get the x value as 0, you are getting x as 0. Now since the x is 0, that's our critical point. It is for us to find out whether it is a maxima point or a minima point. So that's what we are going to do next. We've got x as 0 to be the critical point. So we're going to check g second derivative at 0. Let's see what comes. So that's fair enough. You can substitute it here and see what happens. It's negative 2. So 3 times 0 will leave you only with 2. And in the denominator also this is 0. So you will only get 2 cubed. So actually you are going to get minus half actually, which is always less than 0, and therefore your point x equal to 0 is definitely a maxima point. So it's like x equal to 0 is a point of maxima. Okay, then we can find out the maximum value. So therefore we will have g at 0. Let's find out what is g at 0. It's 1 over 0 squared plus 2, which is 1 over 2, and that is your maximum value. The maximum value is half. That's what it is. That's about this problem. Yeah, a bit of working wise there is a bit of work, but otherwise concept wise it's quite simple. So that's how we go about it. There is one more problem in this question number 3, for the question number 3 to get completed. With that problem we'll be meeting in the next video. So that's all for this video. We'll meet in the next video. Thank you.